We've got two word problems that we're going to go through. The first one, the flight of a baseball, can be modeled by the function h at t equals negative 5.2 t squared plus 3t plus 0.5, where h at t is the height in meters at t seconds. How long will it take for the ball to hit the ground? Now, when I'm asking for how long will it take for the ball to hit the ground, we have to kind of think about, what do I know about this equation if the ball is hitting the ground? Well, this equation is in terms of height and in terms of time. I don't know the time when it hits the ground. That's actually what they're asking me to find. So you might try to just write down for a second here, what am I given and what am I trying to find? I'm trying to find the time, the t value. The thing that I'm given is that it's hitting the ground, and that tells me the height. If I'm hitting the ground, then the height is equal to 0. Now don't forget, instead of just writing h, we're using function notation, so h is always h at t. So h at t equals 0, and we want to find the t value that'll make that true. So that means that my equation, h at t equals negative 5.2 t squared plus 3t plus 0.5, is now equal to 0. And I want to know what's the value for that t that would make that true. Now when I look at this equation, I could try to factor it and ask myself, what two numbers multiply to a half times negative 5.2? But that's a decimal, and I don't want to have to worry about that. So whenever it's decimals for my coefficients, I can use the quadratic formula right away. So don't forget, the a value is the coefficient of the squared term. The b value is the coefficient of the regular term. And the c value is the constant. So here, instead of x is equal to negative b, it's t is equal to, because our variable is t. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll sub that in. Don't forget to go back and extend. I've drawn my root bar too short, so I need to come back and extend it so it goes right to the end. And then my fraction bar goes underneath all of it. Oops, I subbed in the wrong value there. And now what I'm going to do is just simplify the number underneath the root and simplify the denominator. Now, since we have a decimal under the square root, we can't simplify it using our same rules. And the question's asking for the time that the ball hits the ground, so I don't really want to say the time is equal to something with a square root in it. That doesn't really make sense. So because of our word problem context, we are just going to change the time into a decimal. So that tells me that the time is equal to negative 3 plus the root divided by negative 10.4, or negative 3 minus the root. And I'll calculate both of those values. So for this first one, I get negative 0.135, approximately. And for the second one, I get positive 0.71. Now the negative time interval doesn't make sense because our model starts at 0 seconds. So it's not applicable in this story. And so therefore, we know that the ball, that'd be like if the ball was going backwards through time, it would have been on the ground before he kicked it. Or sorry, before he threw it, I think. Is he throwing it? So now I know that the ball hits the ground at 0.71 seconds, so about 3/4 of a second. All right, our next word problem is about a rectangle that has an area of 400 meters squared. It says one side of the rectangle is 5 meters longer than the other side. What are the dimensions of the rectangle? So I've got a rectangle, and it might always help for us to draw a picture of this. Now, kind of like our fencing questions, we don't want to have two different variables here. I know, and I'm going to leave a space here. I'm going to come back and write some stuff up there. I know that in order to find some information about the shape, I'm going to use the area formula because they told me in the question that the area is 400 meters squared. So that's great, except I've got still the length and the width here. So I want to be able to get rid of one of those two variables. And to do that, I'm going to use this fact that one side is 5 meters longer than the other side. So instead of using L and W, I can think about the fact that the L side, I've drawn it as the longer side, it's actually 5 meters longer than the W side. So whatever the W number is, I can find the length number by adding 5 to the W number. Now we know that the area is, oops, I forgot to replace the L, is 400. And we've decided that the length of the shape is W plus 5. And we're going to multiply that by the width. I've changed my mind. I'm not going to come up here and write anything. Now I want to solve this. So I want to know what is the number for W that would make this true. So in order to do that, I am going to try to make one side of the equation equal to 0. But before I do that, I'm going to expand out the right-hand side. You could have moved the 400 over first and then expanded. I think it's just a little less confusing if we expand first. So I'm going to bring the W into the bracket and multiply it by both of those terms. W times W is W squared, and W times 5 is 5W. And now I can bring that 400 over and subtract it. So at this point we're solving. We're trying to figure out what's the number for W that makes this equation true. Oops. So again, I'm going to take a look at my simple trinomial factoring. It tells me to look for a product of negative 400 and a sum of positive 5. And when I go through all the possibilities here, like 40 and negative 10, negative 20 and positive 20, I see that I can't actually get a sum of 5 with any of my pairs. So you could exhaust that list and keep going, but it's not going to work. So I need to use the quadratic formula again for this question. Again, I don't have an x variable, so it's W equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to sub in my values. My b value is 5. My a value is 1. My c value is negative 400. Don't forget to extend that radical bar all the way to the end of the 400. And your fraction bar should go all the way from the negative 5 to the end of the root. Simplifying under the root, we get 1,625, and our denominator is 2. Now again, because we're solving for the width, there's not a lot of applications where you would talk about the width in terms of the square root of something. Normally we would change the width to a decimal. So we're going to do that here. And we're just going to separate out the plus and the minus and then type it into our calculators. When you type this into your calculator, make sure you're doing it along with me and that you do know how to get the right answer. One of the common errors that people make is they just type in negative 5 plus root 1625 divided by 2. If you just type that in exactly in that order, most calculators will only divide the root 1625 by 2 and not the negative 5. That means you're going to get the wrong answer. So in order to force it to do that, you need to remember that there are invisible brackets around this numerator that force BEDMAS to do the adding before it does the dividing. Otherwise, your calculator will do BEDMAS. So you either need to put those brackets in on your calculator, or when you type the numerator in, you have to hit equals before you divide by 2. Either one of those strategies will get you the right answer. You should get about 17.66 and about negative 22.66. But the width, of course, can't be negative. That doesn't make sense. Now the question asks, what are the dimensions of the rectangle? So we know, therefore, the width is 17.66 meters. And the length, we know that the length is 5 more. So it's 17.66 plus 5, which is equal to 22.66 meters. The question could have asked something else, like maybe what is the perimeter of this rectangle, but they've just asked for those dimensions. All right, for your homework, you're on page 177. Questions 4, 5, 8, 9, 11. And then if you need a challenge, or you want to get prepared for those thinking questions on your test, try 12 and 13. Have a great weekend.